Welcome back to today's Explainer. We are skipping the mechanical chaos of traditional cars today to look at the incredibly elegant interconnected systems that make modern electric vehicles run. We're going to break down the actual anatomy of energy and look closely at the core components that make these machines tick. So, think about it. What exactly makes an EV run without a single drop of petrol or diesel? When you see one gliding silently down the street, there are absolutely no miniature explosions happening under the hood. It's just brilliant, pure engineering at work. And today, we're going to map that engineering out. You know, a traditional internal combustion engine is, well, it's a lot. It relies on thousands of tiny moving parts, those miniature explosions, and totally complex exhaust systems. Contrast that with an EV, which runs on a beautifully straightforward and highly efficient flow of electricity. It's incredibly clean and, honestly, surprisingly simple once you see the big picture. To really wrap our heads around this, let's track just a single watt of energy. We're going to follow it as it moves through the vehicle, from how it gets stored to how it's actually converted into physical motion on the road, and finally, how the car charges right back up for tomorrow's commute. Okay, part one, the heart and muscle. The high-voltage battery pack is quite literally the heart of the EV. We're talking hundreds, sometimes even thousands of lithium-ion cells packed together, and this whole setup can weigh well over 1,000 pounds. It stores all the vehicle's electrical energy. Measured in kilowatt-hours, this capacity is the ultimate dictator of your driving range. Simply put, bigger capacity means you go farther. Now, if the battery is the heart, the electric motor is absolutely the muscle. This is the part that actually converts the battery's electrical energy into mechanical energy so the wheels can spin. And because it has very few moving parts compared to an old-school gas engine, you get some massive perks. You get instant torque, no waiting for RPMs to build up, which gives you that signature, super smooth acceleration the second you tap the pedal. Plus, it hardly needs any maintenance. Moving right along to part two, translating the power. Sitting right between the battery and the motor is the inverter. You can kind of think of the inverter as the brain of the operation. See, the battery outputs direct current, or DC power, but the electric motor, it actually needs alternating current, or AC power, to spin. The inverter handles this vital conversion. On top of that, it controls exactly how much juice reaches the motor based on how hard your foot is on the accelerator. But wait, what happens when you pull into your garage and plug in? Well, you're getting AC power straight from the grid. Because the battery only stores DC power, the onboard charger, or OBC, safely takes that incoming AC and converts it into DC. This right here is the crucial bottleneck that actually dictates your home charging speeds. Without the OBC, you just wouldn't be able to charge your car at a standard plug. And what about the radio, or your headlights, or the wipers? They definitely don't need the massive high-voltage power of the main battery. That's exactly where the DC-DC converter comes in. It takes the intense high-voltage DC from the main battery and calms it down to a safe, low-voltage 12-volt DC. In a traditional car, your alternator does this. In an EV, the alternator is officially out of a job. So, just to quickly recap this energy translation matrix. The inverter switches DC to AC for the motor. The onboard charger flips incoming AC to DC for the battery, and the DC-DC converter drops that high-voltage DC down to 12 volts for all your everyday accessories. It's just an incredibly elegant, interconnected ecosystem. All right, part three, protecting the system. Dealing with this much stored energy requires a serious safeguard to prevent any kind of thermal event. Enter the Battery Management System, or BMS. It is arguably the absolute most critical safety component in the entire vehicle. The BMS is essentially a hyper-vigilant supervisor. It continuously monitors the voltage of individual cells, the overall temperature, and the electrical current. It actively stops the car from overcharging at the plug and prevents deep discharging while you're out on the road. It even balances the energy across thousands of tiny cells to guarantee they stay healthy for years to come. Now, pushing all that electricity around naturally generates heat. Both the battery and the motor get warm. So the thermal management system steps in here, using either air cooling or advanced liquid cooling to maintain the perfect operating temperature. Keeping this temperature balanced is so crucial, which is exactly why you might notice your EV losing a little bit of range in the dead of winter. It's literally working overtime to keep its battery warm. Next up, part four, the energy recycler. This brings us to what I think is one of the absolute smartest features in modern EVs, regenerative braking. When you take your foot off the accelerator, the electric motor actually reverses its job. Instead of consuming energy to drive the wheels, it immediately acts as a generator. It captures the kinetic energy of the moving car and turns it straight back into electrical energy. And why does this matter to you? Well, first of all, that recovered energy goes right back to the battery, which instantly increases your driving range. You are literally refueling your car just by slowing down. Plus, because the motor is doing all the heavy lifting to stop the car, your physical brake pads hardly ever get used. This gives us the magic of one-pedal driving and massively reduces your maintenance costs. Finally, Part 5, the complete anatomy. Let's trace the whole ecosystem one last time. The battery pack stores the raw energy. The motor drives the wheels. The inverter controls that motor's power. The onboard charger safely pulls energy into the battery. The DC-DC converter powers your screens and lights. The BMS and thermal systems protect the entire setup. And regenerative braking catches the energy you'd otherwise just lose. Together, these 8 components create perfect mechanical harmony. So, looking at all this incredible engineering, what part stands out to you the most? Is it the sheer density of the battery pack, or maybe the elegant recycling of regenerative braking? Definitely something to chew on the next time an EV glides silently past you. Thanks for hanging out for today's explainer, and we will catch you in the next one.